Hello guys, in this video we are going to be looking at vector analysis. Here we are going to be considering introduction to vectors and scalars, parts of any vector quantity, components of a vector quantity, and problems related to vector quantities. So let's get started. Many familiar quantities in physics have only a number and a unit. Examples are mass, length, time, temperature, current, etc. Such quantities are regarded as scalar quantities. However, most important quantities in physics have magnitudes and direction. For example, to describe the motion of a car, its speed is not enough to do that, but also its direction. Hence, the speed and direction of the car gives what we know to be velocity. Velocity is then known as vector quantity. That means vector quantities are quantities that they have magnitude and direction, while scalars are quantities that only have magnitude and no direction. Other examples of vector quantities are acceleration, displacement, electric field strength, current density, gravitational field strength, and so on. Now that we have understood the basic difference between scalars and vectors, how do we write symbols for vector quantities? Just as we all know, the symbol for velocity is literally given as v, which is small letter v. But in order for us to differentiate between scalar and vector, we don't usually write v, because this v also represents the symbol for speed. So to differentiate between speed and velocity, we use v and we draw an arrow, and this represents velocity. So with the help of an arrow, we can differentiate between scalar and vector quantities. Another example is distance and displacement. Distance is given as d, displacement is given as d, and we indicate with arrow. If we do not use an arrow for the displacement, we are simply writing distance. But so for us to differentiate between distance as a scalar quantity and displacement as a vector quantity, once we use an arrow at the top of d, then it represents displacement. So in vector quantities, an arrow helps us to differentiate it from scalar quantity. Another example is acceleration. Acceleration vector is a, and we put an arrow at the top, and this way we can symbolically differentiate between scalars and vectors. Now, how do we write vectors geometrically, or how do we draw a vector? Like we have said, a vector we have magnitude and direction. So we make use of a straight line which represents the length to indicate magnitude. Then we use arrow to talk about the direction of a vector. So the magnitude of a vector is represented by a straight line to show the length of the line. Then the direction is indicated by an arrow. Let's take, for example, we have this. This is not a vector. This is a straight line. But to make it a vector, we use an arrow. Now, this is a vector. Let's call it vector A. This vector is having magnitude, which is represented by this. Then the direction is represented by the arrow. Another example is this. This is not yet a vector until we put an arrow. Now we can call it vector B. So a vector will surely have magnitude, which is represented by a straight line. Then the direction is represented by an arrow. Now, how do we know the head of a vector and the tail of a vector? The head of the vector is where the arrow is located. So this represents the head of the vector. While the tail of the vector is this. Another one is vector B. So for vector B now, its own head is where the arrow is located and its own tail is the other side. Since we have understood how to draw vector and the symbols for vector, let's take a look at the conditions that will make two or more vectors to be equal. Let's take, for example, we have this vector A and we have another vector B. Vector A and vector B, they are not equal. Even though they are moving in the same direction, they are not equal in magnitude. So we cannot say vector A is equal to vector B. Another one is if we have this vector P and vector Q. These two vectors are only equal in magnitude, but they are traveling in opposite direction. Here, vector P is equal but opposite to vector Q. Now, how can we now say that two or more vectors are equal? We have looked at a situation whereby they are moving in the same direction but having different magnitude. We have looked at when they are traveling in different directions but they are having the same magnitude. So what if we consider these two vectors? Vector R and vector S. We can say that these two vectors are equal because they are traveling in the same direction and they are having the same magnitude. So vector R is equal to vector S, which simply means that two vectors will only be equal if they have the same magnitude and the same direction. Now, let's move to the part of a vector. A vector or any vector quantity will always have two parts. That is direction and angle. Let's start with direction of any vector A. A vector has four directions. We have positive x, which is also known as east. We have positive y, also known as north. Then negative x, also known as west. And negative y, also known as south. A vector can be traveling in any of these directions. Now, let's get it better. Let's start by differentiating the positive and negative x-axis of any vector. Like I have said, this is the positive side of the vector, negative side. That means any object that is located in this straight line that I'm drawing, as you can see on the screen, any object that is here is having a positive direction. Then any vector that we have along this side is having a negative direction. Then let's consider the y-axis as well. Like I've said, this is positive y. So any object that is located upward along this straight line that we can see on the screen is having a positive y-axis. But if the object is located this way, then it's having a negative y-axis, since this side is negative y-axis. So a vector will always have 4 directions. Now let's take a look at a basic example to help us buttress what we have said. You can see on the screen, you are going to travel 300 km due east and then travel 100 km due west. Calculate its total distance and total displacement. So in order to solve this, the knowledge of this scalar and vector quantity is important. As we know, distance is a scalar quantity while displacement is a vector quantity. So when dealing with distance, we don't need to consider direction. So D1 is 300 km, D2 is 100 km. Since it is distance, we are not interested in the direction. So total distance is going to be D1 plus D2. And that will give us 300 plus 100 to give us 400 kilometers. That's the total distance he has traveled. Then the big part, so you should solve for total displacement. Since displacement is a vector quantity, there's need for us to look at direction. So for the first value, it said walk 300 km due east. As we have said, east is positive direction, that's plus 300 kilometers. Then the second value, 100 km due west. West is negative x-axis, that is minus 100 kilometers. Therefore, the total displacement is going to be 300, that's plus 300 plus minus 100, and that gives us 200 kilometers. So he has only displaced 200 kilometers. So this is a practical example of the basic difference between distance and displacement. In vector quantities, we need direction in order to solve problems related to any vector quantity, but for scalar quantity such as distance, we don't need to take direction into consideration. Now that we have looked at the direction part of any vector, now let's talk about the angular part of the vector. Like we have said, there are 2 parts of any vector. We have the direction and we have the angle. So we are going to be starting with the first part of the angle, which is angle from 0 to 360 degree. That means the angle ranges from 0 to 360 degree. Mathematically, it means 0 less than or equals to theta or alpha is 0 less than 360 degree. So let's look at it together. We are moving counterclockwise, that's against the direction of clock. We start from the positive x-axis, as we know. Starting with the positive x-axis, we have the value to be here, then that is 0 degree. So we move this way. We are going to cover 90 degree. So on the positive y-axis, which is also known as north, we have 90 degree. So from the positive y-axis, we continue moving to the negative x-axis. We also cover 90 degree. Then here we are going to be having 180 degree. That means the negative x-axis is 180 degree. They'll move from the negative x-axis to the negative y-axis. Then we have negative y-axis, which is also represented by north. So here we are going to have 270 degree because we are going to cover another 90 degree. So on the negative y-axis, we have 270 degree. So from the negative y-axis to back to the positive x-axis, we cover another 360 degree. This simply means that any object that we have on the positive x-axis is having angle of 0 degree. If the object is located on the positive y-axis, is having angle of 90 degree. If the object is located on the negative x-axis, then it is having angle of 180 degree, which is opposite of 0 degree. Then if the object is located on the negative y-axis, then having angle of 260 degree. Then on the positive x-axis back, we have 360 degree. Like we have said, that means we have it this way. Any object that we have along this side is having angle of 0 degree. Any object that we have on the positive y-axis is having angle of 90 degree. But if the object is between positive y-axis and positive x-axis, for example, we have object here, Q. That means the angle is between 0 to 90 degree, and this kind of object is located in the first quadrant of our coordinate system. But if the object is located on the negative x-axis, then it is having angle of 180 degree. But what if the object is now between positive y-axis and negative x-axis? For example, we have vector u between negative x-axis and positive y-axis. That means it's going to be having angle between 180 degree and 90 degree. And if the object is located on the negative y-axis, it's going to have angle of 270 degree. What if the object is located between negative x-axis and negative y-axis? Then it's going to be having angle between 180 and 270 degree, and we have it to be third quadrant, while this represents second quadrant. Then if the object is between negative y-axis and positive x-axis, the angle is between 270 and 360 degree, and it is located in the fourth quadrant. Now let's look at another approach. We have the other one is 0 to 90 degree. This simply means that we have 0 less than or equals to theta less than or equals to 90 degree. How to use this method, because it is easier to work with than working with 360 degree. This simply means that the angle is always between 0 to 90 degree. We don't want to go beyond 0 to 90 degree. We don't want to reach 270, 180 or 360 degree. So how do we make use of this angle? Starting from the positive x-axis as usual. As we all know, any object located along the positive x-axis is 0 degree. Then we move from 0 degree, continue to move till we get to the positive y-axis. So there we are going to be having 90 degree. And we said any object located along this positive y-axis is having angle of 90 degree. Then if we move from positive y-axis to the negative x-axis, it's supposed to be 180 degree, but we don't want to go beyond 90 degree. That means we return back to 0. Then what's the basic difference between the 0 that we have on the positive x-axis and that of negative x-axis? For the positive x-axis, we're going to be having a positive 0 there, while for the negative x-axis, we are going to be having negative 0. That means if we have objects located along the negative x-axis, we can take the angle to be 0 degree, but in this case, we are going to include negative. Why? Because the object is along the negative x-axis. Now, if we move from negative x-axis to negative y-axis, which we have here, normally it's supposed to be 270 degree, but we don't want the angle to exceed 90 degree. That means in this case, we return back to 90 degree. But what's the basic difference between the 90 degree that we have on the positive y-axis and that of the negative y-axis? The 90 that we have on the positive y-axis is going to be positive because it is located on the positive y-axis, while the 90 that we have on the negative side of y is going to be negative. So in this case, we are able to maintain the values from 0 to 90 degree. Then from negative y-axis, we move to positive x-axis, then we return back to a 0 degree. So basically what we are trying to say here is that working with 90 degree, on the positive x-axis, the angle there is 0 degree. On the positive y-axis, the angle there is 90 degree. Then on the negative x-axis, the angle there is 0 degree, but it's negative 0 degree because it's on the negative x-axis, while the angle for the negative y-axis is also 90 degree, but it is negative 90 degree because it's located on the negative y-axis. This simply means that 270 degree is the same thing as negative 90 degree. That is what we are trying to see here. So instead of writing 270 degree, I can simply write negative 90 degree, and 180 degree simply means negative 0 degree. So that is how we work with 0 to 90 degree or 0 to 360 degree. So now let's look at the components of vectors. So we can use that to buttress our knowledge about the part of any vector. Components of a vector. Let's take, for example, we have a vector called vector A. We have y-axis and x-axis. As we all know, the vertical line is the y-axis, while the horizontal line is the x-axis. Now we have a vector called vector A, and is having its direction to the horizontal as theta. Now we can close any of the side of the vector so as to form a right angle triangle. So if we close this side, we are closing it vertically, which is forming 90 degree, that's right angle triangle. Then we can try to split this vector A. This is going to be the AY, that is the vector along the y-axis, and this one will be AX, vector along the x-axis. As we all know that the vertical line is the y-axis, which is the vertical side. Then we have this line to be the horizontal axis or x-axis. So now we can try to simplify this diagram by saying sine theta becomes opposite. Opposite is where the angle is facing. The angle is facing AY, so we have AY as opposite over hypotenuse. The hypotenuse is the vector itself. Then we try to cross multiply. We are going to be having AY to be equals to A sine theta. You can do the same thing for cos. Cos theta becomes adjacent. The angle is resting on AX. So we have AX over A. We try to cross multiply. We are going to be having AX to be equals to A cos theta. Now we have splitted this vector. The original vector is A. We have splitted it into two. That is along y-axis and along x-axis. So the process of splitting a single vector into its components, that's y and x, that process is known as resolution of vector. Now the AY represents the vertical component of vector A, while AX represents the horizontal component of vector A. Like I've said, the process of splitting this vector A into its components is known as resolution of vectors. Now there's a common misconception about splitting vectors or resolving vectors. You used to have this mindset that once it is y-axis, it has to be sine. Then once it is x-axis, it has to be cos. Actually, I will disagree with that. It's simply because of the way we have resolved the vector. If you look at it on the screen, we resolve it by closing the vertical side. Now we are not going to resolve it by closing vertical side. Let's look at the other way around. We have our y and x axis. Then we have the vector itself is having angle theta, this vector A. Now the other time we resolve vertically, that means we close the vertical line. Here we want to close the horizontal line. We close it this way. That means we are resolving horizontally. Now that we are resolving horizontally, this is the horizontal part of it, like we have said, this horizontal, this one is vertical. So that means this one will give us AX, and the vertical side is no longer here, is along this side, AY. Now this theta is out of the triangle. That means we need to find the angle that is in the triangle. Since everything here is 90 degrees, so for us to get the angle that is here, we label it as alpha, and alpha is going to be 90 minus theta. Basically, what I'm trying to say here is that if we have this kind of vector, if this is 20 degree, that means if you are interested in this side, that will be 90 minus 20, and that gives us 70 degree. Fine. Now we can simplify it by finding sine and cos. So it's now going to be sine alpha is equals to opposite. The opposite is now AX. The angle is facing AX. That is AX over hypotenuse A. So we cross multiply, AX is equal to A sine alpha. Then we have cos alpha equals to adjacent. Adjacent is now AY over A. So we try to cross multiply, we'll be having AY to be equals to A cos alpha. In this case, X is now sine, Y is now cos. So this is to tell us that it is not always X that has to be cos and Y has to be sine. Depends on the way we have resolved the vector. Now that we have understand the components of vectors, that we can have the vertical component and horizontal component, and this is done by either resolving horizontally or vertically. Now let's look at some examples to help us buttress what we mean by resolution of vectors. As we can see on the screen, we have this vector and we have to resolve this vector into components. The first thing is to give this vector, which is 10 Newton, a symbol. Let's say that is F. So this is representing force. So we can resolve horizontally or resolve vertically. Resolve this way. As we all know, this is the positive x-axis, and this is positive y-axis. So if we resolve this way now, then we have this to be Fy, and this will be Fx. That means we find sine and cos theta. Sine 30 degree becomes opposite. Opposite is where the angle is facing, and that is Fy over F, which is the hypotenuse, that's 10 Newton. So we try to cross multiply. Fy becomes 10 sine 30. Now we have to look at the sign. Is it positive Fy or negative Fy? As you can see, the Fy is located on the positive side. Like we have said the other time, for y, we said everything that we have on this side, everything that we have here is for positive y. That means this side and this represents positive y-axis. Then for negative y-axis down, so that means our Fy is positive. Since it's located on the positive y-axis, we can get our value to be plus 5 Newton. Then for cos 30 degree, we have adjacent Fx over hypotenuse, which is F as 10 Newton. So we try to cross multiply. Fx becomes 10 cos 30 degree. Fx becomes 8.66 Newton. Now we need to know the sign for the Fx. As you can see, the Fx is located along the positive x-axis. Like I have said, for positive x-axis is always along this side. Everything that we have along this side is positive x-axis, while everything that we have along this side is negative x-axis. So our fx is on the positive x-axis, so it's going to be plus. So let's look at another example. Here we have to label it as well, positive y, positive x. Here is negative x and negative y. So to solve this, what we need to do is to give our vector, the name of the vector is the unit is meter per second, so the best is to give it velocity. So label it. Now to resolve, we can resolve horizontally or vertically. I just want to resolve horizontally here. Means I'll close this side. Like I've said, the vertical line is this, while the horizontal line is this one. So in that case, we have this one will be Vy. That's where we have our velocity along y-axis. Then this will be Vx. So we can find sine and cos of this by saying sine 20 degree becomes opposite. Opposite is where the angle is facing. The angle is facing Vx this time. Vx over hypotenuse, which is 5. So if you try to cross multiply, Vx becomes 5 sine 20 degree. Now we need to know the sign for the Vx. If you look at it, the Vx is located along the negative x-axis. Like I've said the other time, we have it this way. This negative x-axis. So whatever we have along this side is Vx. Since Vx is located here, along this side, is located here. So that means it's on the negative x-axis. Going to be minus. We have Vx equals to minus 1.71, having the same unit as the original vector. The original vector is 5 meters per second. Let's solve for cos 20 degree. That gives us adjacent. The angle is resting on Vy over hypotenuse. The longest side is 5, which is the original vector. So we try to cross multiply. We have Vy to be equals to 5 cos 20 degree, and we'll be having our Vy to be equals to 4.69 meter per second. But we need to know the sign for Vy. As you can see, the Vy is located on the negative y-axis. Located on negative, like I said, what we have a positive y-axis, everything that we have along this side is positive, everything that we have along this side is negative. So the Vy is located on the negative side, so it's going to be negative value. So that means the y is negative, the x is negative, which is also obeying the law of the third quadrant. That say on the third quadrant, both of them are negative. Now let's look at the last example before we move to the next section of this. Looking at the last example here, we still need to label our point. That's positive y, negative, positive x rather. Then we have negative x. This one represents negative y. Now we are given the vector to be 500 Newton per coulomb, which simply represents electric field intensity, and the angle is 50 degrees. Now we can resolve horizontally or we resolve vertically, but this time I just want to resolve vertically. Feel free to pause the video and try to resolve horizontally to confirm we are going to get the same answer. Resolving vertically means I'm going to close this side. As I close this, 50 degrees out of my triangle, so I need to find the remaining part of the triangle. In this case, we are having it this way. So since it is 90, everything is 90 degrees, so that is 90 minus 50, that gives us 40 degrees. So that means here we are going to be having it to be Ex to represent electric field intensity along the x-axis. Then we have Ey, electric field intensity along the y-axis. So we can solve for Ex and Ey. So that will be sine 40 degree, not sine 50, since I'm not making use of 50 degree is not enclosed in my triangle. Sine 40 degree is going to be opposite. The angle is facing EY. Opposite, that will give us EY over hypotenuse, which is the longest side. That is 500 Newton per coulomb. So we try to cross multiply. EY going to be equals to 500 sine 40 degree. Here we need to know the sign for EY. That means, is it positive or negative? If you look at the EY is located on the negative Y axis. It's not at the top. That means it's going to be negative value. How do we know that? We have discussed it that here is positive, this is negative. So any object that we have here along this side or along this side, they are both going to be negative. But if you have the object or the particle along this side or the vector along this side, then it's going to be positive. But if you look at our EY is on the negative side, so that's why we are putting minus. Then for cos 40 degree, we're going to be having adjacent. Adjacent is now EX over hypotenuse, which is 500 Newton. So we try to cross multiply. EX becomes 500 cos 40 degree. So we need to know the sign for EX as well. Is it positive or negative? But look at the EX is located on the positive x-axis, not along this side. Located on the positive x-axis, so it's going to be plus, which is obeying the law of the fourth quadrant. That in the fourth quadrant, cos is positive and sine is negative. Then we can have our value for EY to be negative. So our EY is negative, while EX is positive. It's 383.02 Newton. So we have looked at the resolution of vectors into its components, that is vertical and horizontal components. We're able to solve for the horizontal and vertical components of the vector, provided that we are given the original vector and its direction theta. We have the vector itself, A, and its direction, and we use this by resolving either horizontally or vertically to get AX and AY. Now, the second case is, what if we are given AX and AY, and we use that to solve for the original vector and its direction? Let's look at it. Let's consider the original vector as this is X, Y. We have the original vector. In this case, it is unknown, and we have its direction. So if we try to resolve this vertically, we have AY and we have AX. In this case, we are going to be giving AX and AY. Now, what we need to do is to use Pythagoras theorem for us to be able to get the value for A and theta. By using Pythagoras theorem, which says that in a right angle triangle, the longest side, which represents the hypotenuse squared, is equals to the addition of what? The other side, that is AX squared plus what? AY squared. So our original vector becomes square root of AX squared plus AY squared. So if you are given the components of the vector, we just need to square them and add them together and find the square root. That will give us our original vector. Then how do we solve for the direction of the original vector? We can either use sine or cos to solve for it, but typically it has its own formula, which is tan. Finding tan, since we'll be giving AX and AY, tan theta becomes opposite is AY over adjacent, which is what? AX, since it is with the horizontal. So that means we use this to find the direction of the vector. While to find the resultant vector, which is the original vector, we use this formula to solve for it. By using Pythagoras theorem, we're able to obtain that. Let's look at one or two examples to buttress this. This example 5 that says, find the magnitude and direction of the vector represented by the following pairs of components, AX and AY. So you can feel free to pause the video so as to give it a try. Starting with the first one. In this case, we are given the components of the vector. So we want to find the magnitude of the vector. Like we have said, we have the magnitude to be equals to square root of the component along x squared, component along y squared. So you can say that the original vector, the magnitude of the vector is going to be, give us ax is minus 9.7. We have to include the sign since we are dealing with vector, plus ay is minus 2.45. The magnitude of the resultant vector is going to be 9 minus 9.7 should be giving us 94.09 plus 6.0025. That will give us 10.0 Newton. That is the magnitude of the resultant vector. And we can find the direction by saying tan theta is equals to, yeah, that's the opposite over adjacent. So we have tan theta is equals to ay is minus 2.45, ax is minus 9.7. That means the negative cancel negative. So having tan theta becomes 0.253. For us to get theta, we find tan inverse, that's arctan of our value, that is 0.253. So the direction of the vector becomes 14.2. Now, in order for us to get the original direction of the vector, we have to draw our components. Again, that's the coordinate system of our vector. If we check the vector, we have the ax to be negative. That means ax is along this side. Then we have ay also is negative. That's they are both on the negative side. That means our resultant vector is in the third quadrant. So how are we going to pick the direction? We pick it with respect to the horizontal. Since we wanted to prove the formula for tan theta, we look it with respect to the horizontal, that's theta, and we say this vector A, and we say that tan theta is equals to ay as opposite over adjacent. So that means we need to take it with respect to the horizontal. That means this is the horizontal part of it. So our 14.2, which is our calculated angle, is with the horizontal. That's 14.2 degree. This is the representation of the magnitude of the vector. If you don't want to pick 14.2 degree as the angle, we can also take the direction of the vector with respect to the vertical as well. That means to take with respect to the vertical, that would be, since everything is 90 degrees, that means we are going to be having 90 minus 40.2. I'll give us 75.8. We can also take it starting from the positive x-axis, rotating counterclockwise, and this way, take it this way. Since here is 90, we also have 90, everything becomes 180 degree. So in that case, that will be 180 from the positive x-axis to the original vector. We are going to be having it as 180 plus 14.2, and that gives us 194.2 degree. That means we have the angle to be 194.2 degree from the positive x-axis to the original vector, or we have it as 75.8, that is to the vertical side of y, or 14.2 from the negative x-axis. So feel free to try the B parts. You can pause the video to try it. Let's look at it together as well. We want to find the magnitude of the resultant vector and also the direction of the vector. To find the magnitude, use the formula that says ax squared plus ay squared. That will give us square root of ax 7.75 plus minus 2.7 squared. So our value for a becomes 8.21 kilometers. Once we solve for it, this is not in Newton. This is wrong. It's supposed to be in meter according to the unit. A then meter. Let's try to correct that. Then we can find the direction by saying tan theta is equals to ay over a. So we have tan theta equals ay is minus 2.7 over 7.75. We solve for theta, we are going to obtain it to be tan inverse of minus 0.348. Theta becomes negative 19.2 degrees. So for us to be able to get the original direction of the vector, we have to draw our coordinate system. So we have the positive y-axis, the positive x-axis, negative y-axis, and negative x-axis. So according to what we are given, the ax is positive. That means our ax is located along the positive x-axis. But the ay is negative. That means we have it here, ay, that's minus 2.75 along this side. That means we have 1.75 along this side. That means our resultant vector a is along this side, is in the fourth quadrant. That means the angle 19.2 degrees is below the horizontal, and like I said, it's going to be peaked with respect to the horizontal since tan theta is ay over ax. The way we have proved it, that means we have it to be 19.2 degrees. So if you want to take this, then we have to pick the value by rotating from the positive x-axis counterclockwise, and we take it this way. Since we have 90 degree, 90 degree, 90 degree, that's 270. So 270 up to fourth quadrant, we have it to be what? 360 degree. That is, for us to get the remaining angle, that means we are going to be taking 360 minus 19.2. That gives us 340.8 degree. That is the angle starting from the positive x-axis, or 19.2 degree below the horizontal. Let's try to do all these exercises and send our answers through the comment section. If you have any questions regarding this topic, kindly forward your questions through the comment sections. Do these exercises. So thank you for watching this video. Kindly subscribe to my YouTube channel so as to get it anytime I upload new notified.